Hello students and welcome to the RapidX session episode 1. Now since exams are just round the corner, so today we will target to cover up one entire topic of corrosion. To study this topic, actually we will divide it into 3 phases. In the first phase we shall learn about the theories of corrosion. In the second phase we will learn about the different types of corrosion that we can see around us. And in the third phase, we will be dealing with the prevention of corrosion, how to prevent different types of corrosion. So let's give it a quick start. Starting with phase 1. In phase 1, we will discuss about the theories of corrosion. Now we have two main theories of corrosion that are commonly talked about. Number 1 is the dry or chemical corrosion theory. It is also called as direct chemical attack theory. Second theory of corrosion which is proposed is the wet or the electrochemical corrosion theory. You can remember the names of these theories as opposites, like dry corrosion theory and the opposite will be the wet corrosion theory. और जब word wet आ जाता है इसका मतलब moisture या कोई medium आएगा उसके अंदर, that means electrochemical corrosion theory can be the other name because electrochemical cell बन जाता है जब इस तरह का medium आ जाता है बीच में. Okay, solution is there. So we have two theories of corrosion: dry corrosion theory, also called as chemical corrosion theory, also called as direct chemical attack. Second is the wet corrosion theory, also called as electrochemical corrosion theory. ये दो theories हैं corrosion की जो कि हमें study करनी है. Let's start with the first theory, that is the dry or chemical corrosion theory और direct chemical attack theory. इसमें क्या होता है? Actually डायरेक्ट केमिकल अटैक होता है. दैट मीन्स डायरेक्ट अटैक ऑफ द corroding medium is taking place on the piece of the metal. Suppose we have a metal surface over here. So what happens? This metal surface is attacked by the dry gases which are present in the environment or any medium which is present in the environment and is enough to make the metal surface corrode. Okay, so these dry gases, they directly attack the piece of the metal, and what happens? The surface of this metal, it gets degraded, it gets corroded. And as you also know, what is corrosion? The degradation or the deterioration of the surface of metal, it is called as corrosion. So here also what is taking place? The surface of this metal has been undergoing deterioration because of the attack by these dry gases or either of the dry gas present in the environment, the corroding medium present in the environment. Okay, now this upper layer of the metal surface has undergone corrosion and the corrosion product is there on the upper surface of the metal piece. Now what will happen? This layer of the corrosion product which has formed on the metal surface, actually it will act as a barrier and it will not allow these dry gases to reach the metal piece inside. So it acts as a barrier for these in corroding mediums to reach the inner piece of the metal, and hence in a way we can say that now this corroded layer, these corrosion products, it acts as a protecting layer for the metal surface lying underneath. Now if the thickness of this corrosion product, this layer which is formed on the surface of the metal, if the thickness is less than 300 angstrom, then we call it as a film. Okay, so if the thickness is less than 300 angstrom, हम उसको फिल्म बुलाते हैं. लेकिन अगर thickness जो है वो ज़्यादा हो जाती है 300 angstrom से, तो हम उसको फिल्म ना कहकर हम उसको स्केल का नाम देते हैं. Okay, so in other words you can say that the thickness of the film varies. Actually direct chemical attack by the dry gases on the piece of any metal at atmospheric temperature is a very uncommon phenomena that is observed. Okay, and however, whenever corrosion take place by direct chemical attack, a solid film of the corrosion product is formed on the surface of the metal, usually that we have shown it over here, which then further protects the underlying metal from getting further corroded. Now, one of the most common ways in which the metals are attacked by direct action is by interacting with oxygen. Why so? Because all of us know that oxygen is present in the air around us, everywhere. Okay. So that is why it is seen, it is observed that one of the most common ways in which a metal can undergo the dry corrosion, or let's say chemical corrosion, or direct attack, it is attacked by oxygen, because oxygen is present everywhere, and it is the oxygen which attack the piece of the metal, the surface of the metal. So the metal surface gets corroded, and this is how the theory explains the corrosion process. Okay, and what are those metal surfaces? Definitely, if we talk about different metals, alkali and alkaline earth metals, like for example sodium, calcium, magnesium, you know that these metals, they are present in the first and the second group of the periodic table, and they are known as the most reactive elements of the periodic table. Okay, so what happens? The alkali and alkaline earth metals, they suffer extensive oxidation even at low temperatures also. So we don't need to raise the temperature. Even at low temperature also, these metals can easily undergo corrosion. They easily undergo attack by oxygen. Whereas if the temperature increases, like in some areas the weather conditions are such that they have high temperature, in desert areas we can talk about, okay, and in the other parts of the world. So at high temperature, it is practically almost all the metals can undergo oxidation. So that means none of the metal is safe in those areas, depending upon the different melting points of those metals. Okay. And yes, of course, there are a few exceptions. What are those exceptions? Gold, silver and platinum. So practically all the metals except gold, silver and platinum, they are oxidized at high temperatures. Okay, so there comes the concept of dry corrosion theory or direct chemical attack theory. Okay, now practically all metals, when they get exposed to the air, they get covered with a film of oxide, which we have seen over here, which is actually a few angstrom thick. And you know that the thickness of this layer varies, it can change. Okay, and if the thickness is less than 300 angstrom, we call it as a film, otherwise we call it as a scale. And the scale formation proceeds in two different ways. Okay, one is by the diffusion of oxygen to the metal through the intervening oxide layers which have already been formed. That means this oxygen has found some of the pits, some of the pores on the surface of this layer, so it seeps in through those pores and corrodes the inner metal surface. Okay, and according to the ionic theory of oxidation, the thickness of oxide films on the metal increases because of such kind of diffusion. Okay, and the diffusion of the metal ion also, Mn plus, can also take place through these pores to the outside and thereby undergoing corrosion. So this is the dry or chemical corrosion. Finally, what chemical reaction can you write upon? We can write as M, which stands for the metal surface. It can be any metal surface which is concerned, and oxygen which is present over there, so we get M2O as the oxide layer. Okay, this is the dry or chemical corrosion or direct chemical attack corrosion, which is actually not so commonly observed type of corrosion. स्टडी किया था मेटल के सरफेस पर क्या हो रहा है आपका. Let's try to understand the mechanism of this theory. Okay, it's very simple. Let's say we have a piece of metal. Okay, so this is a piece of metal block. Okay, and here we have taken iron. You can go with zinc also, you can go with copper also, you can go with any metal surface. Okay, since iron is one of the very commonly used metal around us, so we have picked up iron over here. Okay, now what happens on this metal surface? Actually, what has happened, all the three requirements have been fulfilled up. That means separate anodic and cathodic centers are present, a conducting medium is present, and yes, of course, a potential difference between the between the cathode and anode is also present. So what happens next? We see that anode has been formed that means an anodic area has been formed over here. So this is my anodic area and this is my cathodic area. Okay, remember, at anode oxidation takes place. You can also remember this by a certain code, anox. I take it as anox. That means at anode what is happening? Oxidation is happening. Okay, so anox. So definitely if oxidation is happening at the anode, then what will happen at the cathode? Reduction will be happening at the cathode. So like as of now we will remember this phenomena with the help of this small code anox. Okay, fine. So what is happening at the anode? Oxidation is happening. Oxidation means what? Oxidation means loss of electron is taking place. So can I write the simple chemical equation with respect to this? So I write it here. एनोड की अब हम केमिकल रिएक्शन लिखेंगे. एनोड पर क्या हो रहा है मुझे मालूम है, ऑक्सीडेशन हो रहा है. एंड किसका ऑक्सीडेशन होगा? आयरन का. सो आई हैव आयरन ओवर हियर. इट इज अंडरगोइंग ऑक्सीडेशन एंड इट इज गिविंग मी Fe+2 and along with that 2 electrons are given off. Now at anode actually this is happening, this reaction is happening over here at the anode. और यहाँ से जो 2 इलेक्ट्रॉन निकलते हैं हमें मिलते हैं, these 2 electrons they travel to the cathode with the help of the conducting medium. Okay, now it is the turn of the cathode to make use of those electrons. At the same time what is happening? Anode is slowly, the area of the anode is slowly undergoing degradation. Okay, so the iron which was present over here is slowly changing into Fe+2 and giving off 2 electrons. As a result, this anode will be deteriorating like this. So now my piece of metal which is functioning as the part of the piece of metal which is functioning as the anode has actually become like this. Corrosion has taken place. Let's see the story at the cathode. When the electron reaches the cathode, what happens? There are 2 types of reactions that can take place depending upon the condition. Now what are those conditions? Number 1, so we will write cathode over here. कैथोड पर हमारी 2 तरह की कहानियाँ चलेंगी डिपेंडिंग अपॉन क्या हमारे पास इन्वायरमेंट है उस मेटल पीस का. नंबर 1 स्टोरी इज व्हाट? ऑक्सीजन एब्जॉर्प्शन. दैट मीन्स ऑक्सीजन इज प्रेजेंट over there in the environment. So oxygen is present, then what will happen? Oxygen absorption. But if oxygen is not present, then what will happen? Then evolution of hydrogen will take place. So it is hydrogen evolution, the second option. Let's talk about oxygen absorption. So हुआ क्या है? एनोड से इलेक्ट्रॉन जो रिलीज हुआ था वो कैथोड तक आ गया है. ओके, नाउ दिस कैथोड एक्चुअली हैज लेट्स से प्लेंटी ऑफ सप्लाई ऑफ ऑक्सीजन अराउंड इट. सो व्हाट विल हैपन? ऑक्सीजन का एब्जॉर्प्शन होगा एंड देयर माइट बी अ पॉसिबिलिटी दैट द मीडियम एट द कैथोड मे बी एसिडिक. ओके, सो इट कैन बी एन एसिडिक मीडियम. Okay, or if it is not acidic, then it can be a neutral or let's say weakly alkaline medium. Okay, neutral or weakly alkaline medium. Okay, अगर मीडियम एसिडिक है इसका मतलब क्या है? H+ आयंस प्रेजेंट हैं. राइट, सो अगर H+ आयंस प्रेजेंट है दैट मीन्स व्हाट शुड बी द रिएक्शन? ये कैथोड पर H+ आयन प्रेजेंट है बिकॉज द मीडियम इज एसिडिक. ऑक्सीजन इज ऑल्सो प्रेजेंट बिकॉज वी आर टेकिंग द केस ऑफ ऑक्सीजन absorption over here. Okay, and what happens? The electrons are coming from this anode, they are also present over here. Okay, so my final reaction or equation will be H+ and oxygen and electrons will give me H2O. Okay, so this is my balanced equation. वेरी सिंपल टू रिमेंबर, एसिडिक मीडियम है तो H प्लस प्रेजेंट ही होगा. आप कह रहे हो ऑक्सीजन भी प्रेजेंट है, ऑलरेडी आप वो वाला केस डिस्कस कर रहे हो तो ऑक्सीजन भी लिख दो रिएक्शन में, और इलेक्ट्रॉन तो एनोड से यहाँ तक आ ही रहे हैं. तीनों को कंबाइन करके वाटर इज गेटिंग फॉर्म. बट what if the medium is neutral or let's say weakly alkaline? उस केस में क्या होगा आपका, यानी कि water is there, H2O is there, okay, और weakly alkaline है तो some of the OH minus can also be present, और ऑक्सीजन तो present है because medium में आप कह रहे हो ऑक्सीजन is there, and yes of course the electrons are also coming from the anode. So what do I have now? I have these three components and they will give me the product as OH minus. Okay, so this is the case when oxygen is present. That means oxygen absorption is there. Let's discuss the case where hydrogen evolution is taking place. That means there is no oxygen, absence of oxygen is there. इसमें भी दो categories होती हैं, दो situations arise हो सकती हैं, क्योंकि वो situations तो circumstances पे depend करती हैं. So we can have an acidic medium, okay, and yes of course we can also have a neutral medium, or let's say weakly alkaline medium. ओके, एसिडिक मीडियम है तो अब आप बता सकते हैं हमारी रिएक्शन क्या होगी एसिडिक मीडियम में. येस ऑफ कोर्स एसिडिक मीडियम है तो H प्लस प्रेजेंट होगा. इलेक्ट्रॉन आपका एनोड से आ ही रहा है बट यहाँ पर ऑक्सीजन नहीं प्रेजेंट है, सो वी विल नॉट राइट ऑक्सीजन ऑन द रिएक्टेंट साइड, एंड फाइनली और सिंपली आई कैन गेट H2. So that means hydrogen is liberated over here. If the medium is neutral, तो उस केस में क्या होगा, न्यूट्रल मीडियम है यानी H प्लस तो नहीं होगा, but yes what can be there, H2O is there. सेकेंड क्या था हमारा, इलेक्ट्रॉन जो कि एनोड से आ रहा है. येस ऑफ कोर्स हियर ऑल्सो ऑक्सीजन इज नॉट प्रेजेंट बिकॉज वी आर डिस्कसिंग द केस ऑफ ऑक्सीजन एब्सेंस. सो व्हाट विल आई गेट, आई विल गेट H2 एंड अलॉन्ग विद दैट सम ऑफ द OH माइनस. आई विल बैलेंस दिस इक्वेशन, 2 इधर आ गए, 2 इधर आ गया, एंड H2O विल बी ऑल्सो 2. सो हैविंग अ क्विक रिकैप, मैकेनिज्म बहुत सिंपल है याद रखने के लिए. व्हाट इज हैपनिंग, एनोड एनॉक्स से याद रखेंगे हम. एनॉक्स दैट मीन्स एनोड पर ऑक्सीडेशन होता है. एन फॉर एनोड, OX फॉर ऑक्सीडेशन. ऑक्सीडेशन मीन्स लॉस ऑफ इलेक्ट्रॉन. सो सिंपली राइट डाउन द रिएक्शन ऑफ एनोड. आपको इलेक्ट्रॉन लूज करा रहा है, जो भी मेटल प्रेजेंट है वो, जो भी मेटल पीस दिया हुआ है आपको. ओके, सो आयरन विल बी, आई हैव टेकन आयरन, सो इट इज आयरन विल बी changing into Fe+2 and giving us 2 electrons. These 2 electrons will now travel to the cathode with the help of the conducting medium. कैथोड पे जब वो इलेक्ट्रॉन पहुंच जाता है तो आपके पास दो में से कोई एक कंडीशन हो सकती है, या तो ऑक्सीजन प्रेजेंट है वहां पर कैथोड के आसपास, या ऑक्सीजन एब्सेंट है. ऑक्सीजन इफ प्रेजेंट then oxygen absorption will take place, but if oxygen is not present then definitely hydrogen will be evolved. Let's say if oxygen is present, then the conducting medium, the electrolyte, the solution which will behave as an electrolyte over there can be acidic or it can be neutral or alkaline. इनकी रिएक्शन लिखना बहुत सिंपल है. मीडियम एसिडिक है, दैट मीन्स H प्लस आयन प्रेजेंट है, ऑक्सीजन का प्रेजेंस है ही, एंड इलेक्ट्रॉन्स विच आर कमिंग फ्रॉम द एनोड, एंड यू विल गेट H2O. ओके, बट इफ द मीडियम इज न्यूट्रल देन डेफिनेटली H2O है, ऑक्सीजन भी प्रेजेंट है, इलेक्ट्रॉन्स आपके एनोड से आ रहे हैं, देन यू विल गेट OH माइनस. कमिंग टू द केस वेयर इन ऑक्सीजन इज नॉट प्रेजेंट, दैट मीन्स absence of oxygen is there. So what will happen, hydrogen evolution will be taking place. How? Again you can have either of the medium, acidic or neutral or weakly alkaline. Acidic medium है H plus, 2 इलेक्ट्रॉन्स. यहाँ पर ध्यान रखेंगे जो पिछले केस में था, इस वाले केस में हमने ऑक्सीजन लिखा था क्योंकि ऑक्सीजन प्रेजेंट था, वो यहाँ पर नहीं होगा in the reactant. So we will get a simple product, that is hydrogen. If the medium is neutral or weakly alkaline, H2O will be there. Electrons from the anode are coming and reach the cathode, so they will be there. It will be giving us H2 and OH minus. So these are the reactions which will be taking place at anode and cathode. और धीरे धीरे anode का जो portion है वो धीरे धीरे degrade हो जाएगा, and you can see that the piece of metal whose thickness was this much initially has now reduced to the thickness of this much. Okay, so the thickness of the metal decreases with time, at the anode. Now what will happen, what the question arises, okay, anode पे reaction हुआ, anode पर the metal is becoming thinner and thinner and cathode पर reaction हो रहा है, but what is the story about the rust that we see on the surface of the piece of iron? वो जो reddish brown color का rust है वो कहाँ बनता है, वो कहाँ मिलता है? Actually what happens here, the iron Fe+2 which was formed at the anode, okay, Fe+2 जो यहाँ पर बना था, it will move from its place towards the cathode, और cathode पर आपका जो OH माइनस बना है, ठीक है, that will, or any other product which is getting formed at the cathode, it moves from its place. As a result, they finally meet at a point between the anode and the cathode wherein we get the formation of rust. So here the rust will be formed, FeOH whole twice, and hydrated iron oxide will be getting formed over here. So we see the deposition of rust is here, somewhere near anode but between the cathode and anode, okay. And how does that rust form? Anode से आपका Fe+2 iron चला, यहाँ cathode से OH minus चला, so I'll write it down over here. इधर से आ रहा है Fe+2, इधर से आ रहा है OH माइनस, और यहाँ बीच में आकर आपका रस्ट बन गया, हाइड्रेटेड आयरन ऑक्साइड, ओके, Fe2O3.XH2O if you write down the general equation formula for the hydrated iron oxide, okay. Now this is the mechanism or the story about the wet or electrochemical corrosion theory. Now if you try to compare the chemical corrosion with electrochemical corrosion, we see two to 3 points. How can we differentiate between the two? In case of chemical corrosion or dry corrosion, it actually occurs in dry condition. लेकिन जो electrochemical corrosion theory कहता है वो ये कहता है कि ये corrosion जो है it occurs in wet conditions. That means in the presence of electrolyte or let's say moisture. ठीक है. Second point of difference क्या हो सकता है? Chemical or dry corrosion involves the direct chemical attack of the metal by the dry gases or let's say the environment. लेकिन wet और electrochemical corrosion theory के हिसाब से it involves the setting up of large number of galvanic cells. metal के surface पर जगह बहुत सारे galvanic cell बन जाते हैं. जैसे ये anode और cathode है. Similarly इधर breadth में भी, इस metal piece के breadth में भी यहाँ पर there might be this small galvanic cell. ये anode बन गया, ये cathode बन गया. Like there are many small galvanic cells on the surface of the metal. जैसे कि ये इतना portion मिलकर एक galvanic cell बना रहा है. Okay. The third point of difference is that as far as chemical or dry corrosion is concerned, it is explained. This theory explains the corrosion by absorption mechanism. ये theory कहता है कि आपके metal के direct contact हो रहा है gases के साथ. Here dry gas. So we have reached the phase 2 of this corrosion topic, and in phase 2 we will be discussing about the different types of corrosion. But before knowing the different types of corrosion, we should know what are the factors which affect the corrosion. So there are two main factors which can affect the rate of corrosion: the nature of metal and the nature of environment. So the rate and extent of corrosion actually depends majorly on the nature of metal and the nature of environment. अब हम nature of metal की बात करते हैं तो देखते हैं उसमें क्या क्या आता है. It covers number 1 oxidation potential of the metal. Now as far as oxidation potential of the metal is concerned, we should know one thing, that the extent of corrosion, it depends upon the position of the metal in the galvanic series and the electrochemical series. So whenever two metals are in electrical contact in presence of electrolyte, then what happens, the metal which is higher up in the galvanic series, it will undergo corrosion because it will act as anode, and the one at the lower position will act as cathode. So we should know the position of these metals in the galvanic series and the electrochemical series. अगर हम galvanic series की बात करें, it's very simple, it's very easy to remember also. So we have galvanic series. In the galvanic series we have magnesium, zinc, aluminium, and then steel comes, and then iron. And what kind of iron? It is the cast iron. Okay, we have Pb, Sn, Cu and silver. Okay, so as you move up in this galvanic series, the metals, they become more active, and yes, then they act as anode, or they have anodic nature. So magnesium will be an efficient anode as compared to lead, as compared to tin, as compared to copper. And on the other hand, the copper is more cathodic as compared to magnesium. Why? Because as we move downward, their activity becomes less, and let's say they become noble in nature, and they act as cathode. Okay, so that is the reason why we should know their position in the galvanic series. Okay, now if you talk about magnesium, there are some alloys of magnesium also. So where do they lie? Like for example, if I want to use a magnesium alloy in one of my machinery construction, so how should I decide its nature as far as corrosion is concerned? So just remember, all the alloys of magnesium, they lie below magnesium. Similarly, you have aluminium alloys. All the alloys of aluminium, they lie below aluminium. Okay, now we have alloys of copper with zinc and tin. They are brass and bronze. Okay, so brass lies above copper, whereas bronze lie below copper. Okay, and there is an alloy of copper with nickel also. So that will also lie here, but below bronze. Okay, so you have copper nickel alloy over here. This is how the oxidation potential of the metal can affect the rate of corrosion. Second आता है आपका relative area of anode and cathode. मेरा metal का surface है. Okay, metal के surface पर suppose this is my anodic area and this is my cathodic area. Now what happens? आपको मालूम है anode पर oxidation हो रहा है, यानी कि आपके metal ions release हो रहे हैं plus electrons are getting released, and these electrons are going to cathode, और ये cathode उनको consume कर रहा है. Fine. Now, if the cathodic area is more than the anodic area, suppose the anode इतना सा है और cathode इतना बड़ा area cover कर रहा है. Okay. So what will happen? So the cathodic area is more, then the demand of these electrons will increase. Now, once the demand is increased, as soon as the demand is increased, anode has to now speed up its manufacturing process. Okay. So anode पर reaction और तेजी से होने लगता है, so that it can fulfill the demand of the cathode. So such situation should be avoided. Okay, so because whenever such a situation arises, corrosion और तेजी से होने लगता है, and the metal surface gets corroded very fast. This is the role of relative areas of cathode and anode. Next आता है purity of the metal. अगर metal में impurities present हैं, then what will happen? जहाँ जहाँ impurities present होंगे, वहाँ वहाँ छोटे छोटे local areas develop हो जाएंगे cell के, electrochemical cell के, and then the corrosion will start in those areas. For example, if you have impurities like lead, iron or carbon in zinc, then what will happen? At the exposed part of the impurity, and the corrosion of the zinc around the impurity will take place due to the local action, and the rate of corrosion increases with the increasing exposure of the impurities. Okay, this is how the role of impurity plays in the metal. Next is physical state of the metal. Physical state of the metal, actually how does it plays its role? The smaller the grain size of the metal or the alloy, the greater will be the solubility. As compared to the macroscopic size crystals. In other words, we can say that homogeneous alloys should be present because their mixing of the finer particles is taking place. So the smaller the grain size. Okay. Next is the nature of the oxide film. Agar oxide film porous है, so definitely those pores will allow the oxygen to seep in and reach the underlying metal, and the corrosion will keep on going. Okay, or in other words, on the other way around, the metal ions can move up through those pores and come in contact with oxygen, and again the corrosion process will move on. If the film is stable, then what will happen? Metal के surface पर एक corrosion की layer stable, जो कि stable है, वो बन गई है, तो वो layer अब आगे के corrosion को रोक देगी. Next is if the film is unstable. अगर film unstable है, that means it can revert back to its original products, or let's say reactants, or it can revert back. Then what happens? एवरी टाइम द फिल्म इज फॉर्म इट इज अनस्टेबल, इट गोज, या तो वो रिवर्ट बैक हो जाएगी या फिर वोलेटिलाइज नेचर की होगी तो वो वेपराइज हो जाएगी. ठीक है, तो इन दोज केसेस एवरी टाइम द फ्रेश surface of the metal is exposed for further corrosion. So that is how the nature of the oxide film plays its role. Next is solubility of the products of corrosion. The solubility of the corrosion products which are formed is actually an important factor. Why? Because if the corrosion product is soluble, the corrosion of metal will proceed with a faster pace. On the other hand, if the corrosion product is insoluble, like it is in many of the metal oxides cases, okay, then what happens? It will form a protective film to avoid further corrosion. So these are the factors, sub factors under the nature of metal. Next we come to the nature of environment. Nature of environment, number one, temperature. Definitely temperature हम बढ़ा देंगे तो corrosion का rate बढ़ जाएगा. Okay, so the rate of chemical corrosion and the rate of diffusion increases with the temperature, and hence in general it may be said that the corrosion increases with the temperature. Okay, next is presence of moisture or humidity. This is mostly happening because moisture is present, that leads to the development of the electrochemical cell, and that will lead to the increased rate of corrosion. Next, pH, effect of pH. Actually the hydrogen ion concentration of the medium is one of the important factor that can affect the rate of corrosion. Why? Because acidic medium जो है वो corrosion को promote करता है. In other words, अगर pH decrease होता रहेगा, if we have a lower value of pH, then what will happen? The medium becomes acidic, and the acidic media are generally more corrosive in nature as compared to the alkaline and the neutral medium. Many materials we have seen that they can be resistant to the alkalis, although they are readily attacked by the acids. So in these cases corrosivity can be reduced. How? By increasing the pH of the solution. So pH can also have a major role to play in the resistance, specifically if we talk about the pitting and the stress corrosion, cracking. These are the types of corrosion that we will discuss in our next slide. Next factor which comes under the nature of the environment is the nature of the ions present. It can be cation or anion, which also can affect the rate of corrosion. How? Like for example, chloride ion, which is, if it is present in the medium, it destroys the passive film which has been formed on the surface of the metal and corrode many metals and alloys. That means the corrosion increases. On the other hand, there are certain anions like silicate, which actually form insoluble reaction product, and it further inhibits corrosion. Another example we can take of, अगर copper के traces present है या कोई noble metal present है, then what happens? Traces of copper or more noble metal accelerate the corrosion of the iron pipes, which are used actually to carry mine water. So many metals including iron corrode more rapidly in the ammonium salts than in the sodium salts of identical concentration. Next is the nature of impurities present in the air. Yes, of course, air contains many gases, as well as these gases also can function as an impurity, or we also see that the air of different areas is having different nature. Like for example, in marine atmosphere, the presence of electrolytes such as NaCl is there, and yes, of course, the air is humid also. This leads to the increase in corrosion of the metal. Similarly, if we talk about the atmospheric air near some industrial area, so what happens? उन industries से जो gases निकल रही हैं, the acid fumes and gases which are coming out of those industries, like it can be H2S, it can be SO3, CO2 or SO2. What happens if the water in is present in the nearby areas, and these gases or fumes, they get dissolved in that water, and the water becomes acidic mostly, okay, as it is observed. And when this water comes into contact with the metal surface, its electrical conductivity increases. So definitely that naturally increases the corrosion rate. So these are the factors which affect the corrosion. Now let's talk about the different types of corrosion. Number one, galvanic corrosion. गैल्वेनिक करोजन एक्चुअली तब होता है जब आप कोई भी दो डिसिमिलर मेटल्स को जोड़कर कोई एक अपना इंस्ट्रूमेंट का या मशीन का पार्ट बनाते हो या वहाँ पर यूज़ करते हो, या लेट्स से पाइपलाइंस में. सो गैल्वेनिक करोजन इज कॉज व्हेन टू डिसिमिलर मेटल्स आर इलेक्ट्रिकली कनेक्टेड विद ईच अदर एंड देन दे आर एक्सपोज टू द इलेक्ट्रोलाइट. सो व्हाट हैपन्स व्हेन द टू मेटालिक पार्ट्स दे कॉन्स्टिट्यूट अ गैल्वेनिक सेल, and in which the metal with the lower electrochemical potential, that means the more active metal, will get corroded, and the other one will leads to the corrosion. For example, अगर हमारे पास zinc और copper है, so let's say I have this structure wherein I am taken zinc and copper. So this part is zinc and this part, they both are connected together. This part is actually made up of copper and they are exposed to the conducting medium which act as electrolyte. Okay, so what happens, zinc and copper are in contact with each other in the presence of electrolyte. Then what happens, you know that zinc is higher up in the electrochemical series or the galvanic series that we just mentioned as compared to copper. So this zinc will act as anode. So if zinc is acting as anode, it will lead to its oxidation, so it will form zinc ions and electrons. Now these electrons will move to the cathode, that is copper over here. So copper will behave as a cathode and zinc will behave as anode over here. Okay, so zinc forms the anode and it gets dissolved or it gets corroded, while the copper, which is lower in the series, it acts as cathode and it is protected. Okay, so slowly and gradually after few days, what will we observe? This zinc will become thinner and thinner because it is leading to corrosion or deterioration, and slowly and gradually this part will become thinner. So the use of copper pipes in conjunction with the iron pipes in water distribution systems has been the cause of galvanic corrosion. There the iron, which act as a anode, it corrodes, so iron corrodes over there, whereas the more noble copper act as cathode and it is protected. So this is galvanic corrosion, which is actually linked up to the galvanic series. Next is concentration cell corrosion. In concentration cell corrosion, actually two or more areas of the metal surface are in contact with a different concentration of the same electrolyte. So as the name suggests, concentration is playing a role over there. Okay, so the metal surface is exposed to different concentration of the environment. Let's see how it goes. Under the concentration cell corrosion, we can talk about differential oxygen concentration or aeration concentration. Here what is happening, the oxygen concentration is different. How do we see that? Let's see. We have a beaker, and this beaker or a container, it is filled with NaCl solution. So I have put NaCl in it, and then I dip a rod which is made up of zinc in this. Okay, so what happens, actually the portion, the NaCl level is this. Okay, so the portion of the rod which is below this level is getting a lesser supply of oxygen as compared to this portion of the zinc rod which is freely exposed to the oxygen. So less aerated part becomes the anode, or it starts behaving as anode, and the more aerated part will start behaving as a cathode. Okay, so as soon as the anode and cathode are set up, electrolyte is available as NaCl. What happens? Chemical reaction will start. So this part of the metal will show the chemical reaction as anode. That means zinc will be oxidized to Zn plus 2, giving us 2 electrons. Now these 2 electrons will travel to the cathodic area, and at the cathode, you know, oxygen is very well present. So what will be the reaction over there? It will be oxygen, okay, and the moisture which is present and the electrons which have traveled so far away from the anode, they will be reacting and giving us OH minus. Okay, now these OH minus and zinc will be moving from their individual places, and they will meet in between, in the middle, somewhere in between anode and cathode, and the corrosion product is formed. So in that case, if the zinc metal is partially immersed in a dilute solution of NaCl and the solution is not stirred, the parts above and closely adjacent to the water line are well aerated. They have a good supply of oxygen. Whereas on the other hand, the area which is deep inside the solution वो anodic बन जाता है क्योंकि वहाँ पर concentration oxygen का कम होता है as compared to the exposed part. Thus a potential is developed which causes the flow of current between the two areas of the same metal. एक ही metal था, same metal था, उसके surface पर different concentration है at different areas किसका? Oxygen का. Okay, so this leads to the corrosion of the zinc rod. Next is under the same category, other examples of corrosion by differential aeration are, let's say, the drop corrosion. Okay, now what is the drop corrosion? Let's see, we are sitting over there having our snacks, and during our party time I just happened to drop this some of my juice or some of the drink that I was having. So what happens now? You have this drop on the metal surface. Let's have a zoom in view of this table. So this was my table and I spilled some of the cold drink, or let's say juice, that I was having, and this is the drop that I spilled on it. Now what happens? Drop corrosion actually take place when a drop of electrolyte solution is in contact with the metal surface. Like for example, I just mentioned I happen to drop some of my juice or let's say a cold drink on the surface of this metal. So rusting occurs in the central region beneath the drop. Why? Because the periphery means this part of the drop. The periphery of the drop, if we talk about this portion, यहाँ पर इसको metal surface को good supply of oxygen मिल रहा है. But if we talk about the central part, this middle, at the center of this drop, here oxygen supply is very, very less. So what happens? This part of the table which is lying under the drop that I spilled, it will start behaving as anode, और ये वाला part जो periphery की तरफ है, ये वाला part इस table का, it will start behaving as a cathode. So as soon as the cathode and anode are set up, and yes, of course the drop is providing the electrolyte, then what happens? A small galvanic cell is set up and the corrosion starts. So what will happen? Anode है आपका, let's say my table was made up of iron, so this will, at anode, this reaction will take place, Fe+2 and 2 electrons, and these 2 electrons will travel at the cathode. कैथोड पर ऑक्सीजन का सप्लाई अच्छा खासा है. सो व्हाट कैन हैपन? ऑक्सीजन इज देयर, इलेक्ट्रॉन्स भी आ गए हैं एनोड से, मॉइस्चर भी प्रेजेंट है, एंड दे विल फॉर्म OH-. ओके, नाउ द Fe+2 आयन मूव्स टूवर्ड्स द कैथोड. यहाँ से Fe+2 चलेगा यहाँ, और वहाँ से OH- चलेगा. सो व्हाट विल हैपन्स? These two combine in between to form the rust. Okay, these will form FeOH whole twice, which will further subsequently lead to the formation of rust, Fe2O3.XH2O, that is hydrated iron oxide. So this is an example, or let's say a subtype, and it is called as drop corrosion. Similarly, you have waterline corrosion. Now this type of corrosion results from differential aeration leading to the formation of oxygen concentration cells. And ये कब होता है? जब आपके स्टील टैंक में पानी बहुत देर से स्टैग्नेंट पोजीशन पर होता है, मीन्स आप उसको हिला नहीं रहे हो. सो इट इज ऑब्जर्व दैट द करोजन टेक्स प्लेस जस्ट बिलो द वाटर लेवल. द कॉन्सेंट्रेशन ऑफ डिजॉल्व ऑक्सीजन एट द वाटर सरफेस इज ग्रेटर than under the surface. What do I mean to say? अगर ये मेरा वाटर टैंक है और ये वाटर से फिल्ड अप है, ठीक है, सो दिस पोर्शन ऑफ द टैंक, इट इज गेटिंग लेस सप्लाई ऑफ ऑक्सीजन एज कंपेयर टू दिस पोर्शन. सो ये बन जाएगा एनोड और ये बन जाएगा cathode. Okay, so this generates a oxygen concentration cell in which the metal at the water level is cathodic with respect to the metal below the water level, which act as anode. और फिर बिल्कुल सेम यही रिएक्शन भी इसके अंदर स्टार्ट हो जाएंगे, ऑनसेट हो जाएंगे. दैट, एंड यू कैन सी ऑन दिस, on the inner lining of this tank, a reddish brown ring is formed at the just below the level of the water. That is called as water line corrosion due to the difference in concentration of oxygen. Next is the crevice corrosion. crevice corrosion में क्या होता है, छोटे छोटे आपके क्रैक्स पड़ जाते हैं. ओके, सो व्हाट हैपन्स इन crevice corrosion? The same thing happens. So this concept will apply everywhere, is applied actually everywhere. So crevice or contact corrosion is the corrosion which is produced at the region of contact of metals with metals or non-metals. For example, आपके पास different metallic objects है, such as आप rivets and bolts का इस्तेमाल करते हो, washers का इस्तेमाल करते हो, nuts का इस्तेमाल करते हो, तो क्या होता है उसमें, ये आपका पीस है, ये हम कह लीजिए ये 2 पीसेस हैं आपके पास, ठीक है, और इनको आपको जोड़ना है विद द हेल्प ऑफ रिवेट और नट बोल्ट वट एवर यू आर यूजिंग. सो आप यहाँ पर एक बोल्ट लगा देते हो, ठीक है. सो व्हाट हैपन्स ओवर हियर, यहाँ पर क्या होता है, ये वाला पोर्शन मार्केट, ये वाला पोर्शन जो होता है, दिस हैज़ लेस सप्लाई ऑफ ऑक्सीजन, वेर एज द पोर्शन विच इज एक्सपोज्ड अपवर्ड, ये दिस पोर्शन ऑफ द मेटल इट हैज़ सफिशिएंट सप्लाई ऑफ ऑक्सीजन, तो ये बन जाते हैं कैथोड. और ये वाला अंदर का पोर्शन जहाँ पर ऑक्सीजन सप्लाई कम होती है, ये बन जाता है एनोड. एंड देन द सेम प्रोसेस स्टार्ट, सेम रिएक्शन टेक प्लेस. ओके, सो whenever these types of contact they come across with some liquid or some moisture, anodic region is set up and the cathodic region is set up and the corrosion starts. This type of corrosion is accelerated by the deposition of dirt, debris, etc. जितना गंदगी उसमें जमा होगी उतना ही और ज़्यादा ये corrosion rate बढ़ जाएगा, because these materials they restrict the supply of oxygen अंडरनीथ द कवर्ड पोर्शन. यानी कि ये जो आपने एक बोल्ट लगाया था, ये बोल्ट जो लगाया था आपने, इसके नीचे वाले पोर्शन में अगर गंदगी जमा हो गई है, डर्ट डस्ट डिपॉजिट हो गया है, देन लेसर सप्लाई ऑफ ऑक्सीजन विल बी देयर एंड हेंस द रेट ऑफ करोजन विल इंक्रीज. ओके, नेक्स्ट इज द पिटिंग करोजन. Pitting corrosion is a localized corrosion which results in the formation of pits and or holes you can say. ठीक है, pitting usually takes place due to cracking of the protective film on the surface of the metal. होता क्या है कि आपका जो metal का surface है, let's say उसके अंदर crack पड़ गया है, ठीक है, मेटल का सरफेस है, ये सपोज मेरा ये मेटल का सरफेस था और इसमें क्रैक पड़ गया है. सो द मोमेंट अ क्रैक इज फॉर्म, तो क्या होगा, ये अंदर वाले पोर्शन में ऑक्सीजन सप्लाई कम होगी एज कम्पेयर टू दी एक्सपोज पार्ट. यहाँ पर ऑक्सीजन सप्लाई ज़्यादा होगी, यहाँ पर ज़्यादा होगी एज कम्पेयर टू दिस पार्ट. ओके, सो ये बन जाएगा एनोड और ये सरफेसेस बन जाएंगे मेरे कैथोड एंड द सेम रिएक्शन अकर्स. ओके, after pitting corrosion we have intergranular corrosion. Intergranular corrosion में क्या होता है, it happens when the molten metal is solidified. तो होता क्या है, solidification process start होता है और उस टाइम पर number of randomly distributed nuclei within the molten mass are present and each of them grow in a different pattern, in a रेगुलर पैटर्न ऑफ देयर ओन काइंड. ओके, लाइक फॉर एग्जाम्पल मेरे पास मोल्टन मेटल है और वो अब सॉलिडिफाई कर रही हूँ मैं, ठीक है, वी आर टॉकिंग ऑफ इंटरग्रैनुलर करोजन. उस मोल्टन मेटल को जो हम सॉलिडिफाई करते हैं तो ये डिफरेंट ग्रेन बन जाते हैं, ग्रेन्स बन जाते हैं. वाई, बिकॉज दीज एटम्स दीज आर अलाइन इन दिस डायरेक्शन. यहाँ पर क्या है, डायरेक्शन डिफरेंट है. सो जो इस डायरेक्शन के हैं वो एक ग्रेन बन जाता है एंड लेट्स से दिस दे आर अलाइन इन दिस डायरेक्शन, सो वो दूसरा एक और ग्रेन बन गया और ये सब का सब एक ही मेटल पीस के अंदर हो रहा है प्रोसेस. ओके, so grain boundaries are generally more prone to corrosive attack. This is due to the fact that the precipitation of certain compounds occurs at grain boundaries. So होता क्या है, precipitated compound as well as the grain centers they behave as cathode whereas the grain boundaries behave as anode. तो ये बन जाता है, जो बाउंड्री है, ग्रेन बाउंड्रीज है, ये एनोड बन जाता है और जो सेंट्रल पोर्शन है, ये पोर्शन है, ये आपका कैथोड बन जाता है. Okay, so grain boundaries behave as anode, and this is because the precipitation of certain compounds at the grain boundaries they leave the solid metal solution adjacent to them. Okay, and then in this process they deplete in one constituent. इससे क्या होता है, ये edges यानी boundaries और center के बीच में एक potential develop हो जाता है. fine, and the corrosion starts. So that is intergranular corrosion. Next is the stress corrosion. स्ट्रेस करोजन में क्या होता है, अगर आप किसी मेटल पीस को एक शेप देना चाह रहे हैं, उसको मोड़ना चाह रहे हैं, तो क्या होता है, जिस जगह से वो मुड़ता है, द पार्ट ऑफ दैट मेटल पीस विच यू आर ट्राइंग टू बेंड, ओके, एक्चुअली अगर आप ध्यान से देखें, यू आर गिविंग स्ट्रेस टू दैट पोर्शन ऑफ द मेटल पीस, ओके, सो दैट लीड्स टू stress corrosion after some days or after a few months. Okay, stress corrosion or cracking is it is unpredictable in nature. Even after a few years of trouble-free services from the companies, a metal can suddenly crack without any warning or previous deformation. अचानक से वो crack हो जाएगा उस जगह से. Okay, so the term stress corrosion takes place due to the combined effect of mechanical stress and the corroding environment on that piece of metal. So this actually happens. Why? Because during the fabrication of that particular machine or device, these materials are subjected to different types of uneven stresses such as rolling, drawing, annealing or bending, जैसे मैंने अभी mention किया. Okay, so in such cases the metal under the stress becomes more anodic as compared to the areas which act as cathode. मतलब अगर मैं ये piece of metal है, suppose this piece of metal is there and I am trying to bend it and I have bended it this way. So ये portion जो है उसको बहुत ज़्यादा stress की का face करना पड़ा. Okay, so this part will act as anode. Okay, and the other one, the part which is inside this will act as cathode, and suddenly one fine day it will crack. So that is stress corrosion. Next है आपका soil corrosion. Soil corrosion, as the name suggests, definitely you can see it in the soil, or it happens in the soil if you have pipelines buried or anything that is lying in the soil can come across soil corrosion. The enormous amount of money we can see it has been invested by the governments on the underground structures and pipelines, which is for the water pipeline or gas pipeline or oil pipelines are going on. Okay, and these are encouraged. Considerable research on the constitution of soil has taken place because these pipelines, they get damaged and they cause heavy economic loss. So there are various factors which are responsible for soil corrosion, like for example acidity of the soil, moisture content of the soil, the content of electrolytes present in the soil, yes, of course, the microorganisms present in the soil, and the physical properties of the soil, they also affect the corrosion rate. Like for example, in non-acid soils, the conductivity, which actually depends upon the moisture content, is the major factor governing the corrosive character. So in such soil, corrosion take place due to the formation of differential aeration concentration cell. Okay. Buried pipelines or cables which are buried in the soil, passing from one type of soil to another, like for example one city to another city, the pipelines are running, so definitely the soil of those cities will be different. It can be different, they might be different. So in that cases, those buried pipelines or cables passing from one type of soil to another type of soil may get corroded due to differential aeration. Other corrosion factors in this case are the differences in pH. There can be a presence of unburned carbon in the cinders, or else the soil of one city or one area can be less aerated as compared to the other one. So in that case, aeration concentration cells develops on that particular pipeline. So this leads to the soil erosion. Next is selective leaching, or you also call it as corrosion, selective leaching corrosion. Okay, इसमें क्या होता है आपका कि आपका जो मेटल का सरफेस है it leaches up. Okay, so it involves the removal of one element from the solid alloy by the corrosion process. मतलब आपके जो अलॉय आप इस्तेमाल कर रहे हैं, इफ़ यू रिमूव वन ऑफ द एलिमेंट, लाइक फॉर एग्जांपल डीजिंकिफिकेशन, इसमें क्या होता है, जिंक को रिमूव करते हैं हम फ्रॉम zinc copper alloy. From brass, zinc is removed. It is a common example of this type of corrosion, selective leaching. Similar processes occur in other alloy system also, like for example aluminium, iron, cobalt and chromium and other elements which are removed from their alloys. So but dezincification is very prevalent in nature in condenser tubes which are made up of brass. So zinc gets removed from it, where seawater is used as condenser water. Okay, so in that case, although both zinc and copper, they go into the solution from these alloys, but only zinc ions remain in solution and copper is redeposited back to these tubes. Okay, so this is because zinc is quite reactive, whereas copper is nobler, if you remember the galvanic series. Hence zinc dezincification proceeds continuously. Next is hydrogen damage. It is a general term जो कि हम यूज़ करते हैं for mechanical damage of the metal which is caused by the presence of hydrogen या hydrogen के interaction से जो mechanical damage होता है. This can be in the form of blisters, it can be making the metal embrittle, or let's say interaction between the metal or the component of the alloy and hydrogen taking place at high temperature. So that is hydrogen damage. Next is stray current corrosion. Stray current corrosion actually is the type of corrosion wherein metal structures such as water pipelines, gas pipelines, your cable sheet, they get corroded due to leakages from the main circuit. So whenever a material is selected for a particular job, special attention should be paid regarding the possibility of the localized corrosion, particularly pitting and stress corrosion. So that is stray current corrosion. Next is the microbial corrosion or microbiological corrosion. Microbial corrosion is the deterioration of the material which is caused directly or indirectly by the presence of the microbes. Yes, and there are some types of bacteria we know that exert some or influence, or let's say they affect on the corrosion process. Like for example, oxygen consuming bacteria, if it is present in water or the soil, it decreases the concentration of the oxygen in the medium which is nearer to the metal surface, and this is how the metal can be like moving towards the corrosion process. On the other hand, you have anaerobic bacteria which do not require oxygen, yes of course, but it reduces sulfates to sulfur, which is used to prepare their protoplasm or their own metabolic processes. So during that process, it is supposed that these bacteria, they convert the oxygen from the sulfates into such a form which brings about a depolarization effect on the corrosion of iron. Okay, so when these organisms die, sulfur is liberated as H2S, and then which converts a portion of the corrosion product into FeS. Iron metal is converted to FeS, which is less effective. Okay, now so corrosion can speed up or take place in that way. The presence of iron bacteria on the other hand is sometimes connected with pitting or blockage of pipes due to corrosion products. Iron and manganese bacteria, which totally thrive on iron and manganese compounds, definitely, and if we are using an alloy which contains these particular metals, then these bacteria can cause a severe damage to those pieces of metals or alloys. So that is microbial corrosion. Next is the erosion corrosion. Erosion corrosion is the result of relative movement between a corroding medium and the metal surface. What happens generally due to the high velocity of the turbulent motion of the fluid, like for example in ships, if it is sailing in the sea. Okay, so the water current, they slowly degrade the surface of the ship, and that is actually we see after a few years that the ship surface has gotten corroded. So this results in the development of because of the development of the differential cells at these points, leading to corrosion. Okay, many metals of corrosive medium moving with the high velocities can cause erosion corrosion. These can be gases, they can be aqueous solutions, liquid metals. For example, hot gases may oxidize a metal. and then at high velocity blow off that protective scale around the metal. So definitely this falls under the category of erosion corrosion. On the other hand, if you talk about desert areas, high wind velocity can cause corrosion of the metal surface. So these are the different types of corrosion, and here we have come to a simple conclusion that all these different types are somewhere related to a common type, that is the difference in concentration. Okay, and with the difference in concentration, and yes, of course, due to the presence of certain microorganisms or the pH, all these factors also are playing role in the types of corrosion. Okay, so finally we have entered the phase 3 of corrosion, and that will deal mainly with the prevention of corrosion. The first point to remember for the prevention of corrosion is proper design and material selection. For that purpose, we should take care that we should not use we should not try to join those metals together which are far apart in the galvanic series, because as you know, the more the distance, the gap between the two metals, the more reactivity of the anodic part will be there, and hence the higher rate of corrosion. So actually, in a way, we can say that design is the initial stage for protection against corrosion. Before a suitable design is made, careful consideration of the constructional material, atmosphere, environmental conditions, and accessibility for maintenance and repair is required. So we should be more focused on the proper designing and material selection. The second point that we need to take care under this section is never use a design with large difference in relative size of anode and cathode. As we discussed in our previous section, the larger the cathodic area, the more will be the demand of electrons, and hence the more will be the speed at which the anodic reaction will be taking place. Okay, so that large difference should be avoided. Third is screws, bolts, nuts and wells should be made from much nobler metals. That means we can have like for example, we have let's compare the two selections. I have a selection wherein I have to use these nuts and bolts. This is an aluminium sheet, okay, that I am taking. Okay, so this is an aluminium sheet, and I have used brass. Okay, the nuts made up of brass. So this is made up of brass. Okay, and yes, of course, in that case this will be my corroded zone. So this is my corroded zone. This is one of my selection. Let's say this is my selection number 1. Okay, on the other hand, what do? I have the same aluminium sheet. Okay, so aluminium sheet here also. Okay, and instead of taking brass, this time I have used a washer which is actually made up of zinc or aluminium. Okay, so this is a washer made up of zinc or aluminium. Okay, fine. And on this we have a bismuth or cadmium plated screw is used. Okay, so bismuth or cadmium plated screw. So the washer is made up of zinc or aluminium, and the screw is plated with cadmium or bismuth. Out of these two selections, this is my selection number 2. The first selection is actually poor selection. Why? Because it will lead to a higher rate of corrosion, whereas this will fall into my good selection. Okay, so the selection material also plays its role. Why does it falls into a good selection? Because here I have used much nobler metals as compared to the metal which I am trying to save, that is aluminium sheet. In the first case, I have a poor selection because I did not use the nobler metals. Okay, so here corrosion will take place. Here corrosion will not be taking place at that easy pace. Okay, as far as your welds are concerned, continuous weld should be preferred, and that can avoid corrosion, because the intermittent welds are unsuitable both from the mechanical as well as corrosion point of view. The smaller size of the weld should be turned towards the corrosive medium. If we talk about the designs, then we should take care that if we have any instrument, or we want to keep a machine, like we start with a very basic. Let's say I have a platform, I have this floor, and we need to keep some machine over here. So these are my two options. Option number one, I just keep that machine or instrument on the floor, and this is how I use it. And my option number two actually says that I use some elevated platform on which I keep my machine. So option number two actually is a better choice. This is a much good option as compared to option number one, which is actually a poor option. Why? Because it is easier to clean this part as compared to this part, and the space between my instrument or my machine and the floor, that space is sufficient enough for dust and dirt to deposit. So the moment that happens, this area definitely it is directly under the instrument or the machine, and moreover it is deposited with dust and dirt. So that area is deficient in oxygen, and it will function as anode. The moment the anode is formed, the nearby area will act as cathode, and the corrosion will start. Okay. So the option number two is a better way of keeping the machines, and the same concept should be applied in making or designing the machines. Okay. Another concept that we can talk about is, like for example, I have two surfaces. One surface is like this, okay, and the other surface is like this. So let's say this is first choice and second choice. In this case, water retention is easy on this surface. Water can remain for some time on this surface, but as soon as it falls on this surface, and choice number two, option number two, it drains out, or it trickles down. Okay, so here water retention is minimum, so this will be my good choice as compared to option number one, which will be my poor choice. Okay, so this is with respect to making a design in which the retention of moisture is minimum. So we should use such kind of designs, we should make such kind of designs. Another aspect, if we have we have bends, in our designs, okay, so the corrosion can be controlled in that designing also. How do we do? Suppose I have this bend, okay, and this is option number one, and I can do it in another form wherein I have this bend. No sharp edges are there. This is my design number two. So in these cases, design number one act as a poor design. Why? Because these sharp corners, they are a good place for the dust and dirt to accommodate. No matter how efficiently, daily, regularly, religiously you clean these surfaces, but you won't be able to take out the dust and the dirt which has deposited over here. As soon as that happens, this part will behave as anode, and the nearby part will behave as cathode. Why? Because anodic region will receive less supply of oxygen. Okay, if we compare this with the second design, this is our good choice of design. Why? Because the curved surface actually can be cleaned up easily. Okay, so in that case you can say that the elimination of sharp corners should be there while making design. Okay, and use of insulated washers should be there, and making provision for proper air circulation, drainage, washing should be taken care of while making a design, and retention of moisture should be minimum. These all are the factors which you can discuss in proper design and material selection. Okay, so the second method by which we can prevent corrosion is the use of inhibitors. Now, what is an inhibitor actually? The literal meaning of inhibition means to prevent. So inhibitors are those chemical substances which prevent the corrosion or which reduce the corrosion rate when they are added in small quantities to the corrosive environment. Now there are different types of inhibitors. So basically 3 types of inhibitors we discuss. So number 1, anodic inhibitor. Anodic inhibitor, as the name suggests, it inhibits or it prevents the reaction of the anode. How do? They react with the ions of the anode and to produce some insoluble precipitate. Like for example, what happens at the anode? We have a piece of, let's say we have a piece of iron. Okay, so this is my iron piece, the surface of the iron, and let's say this is my anodic area. Okay, so what is happening, what reaction is taking place over here? Iron is getting oxidized to Fe+2 and giving us 2 electrons. Okay, so what is this anodic inhibitor doing? It is reacting with the ion of the anode. That means it will capture these Fe+2 ions and convert it into some insoluble precipitate. The precipitate which is formed, it is adsorbed on the surface of the metal, and so this precipitate gets deposited over here and it forms a protective layer or the protective film, or let's say a protective barrier, thereby reducing the rate of corrosion. Okay, although anodic inhibitors, they are not considered to be satisfactory. क्यों? क्योंकि for each inhibitor there is a certain critical concentration of these inhibitors that should be used. It is only when the concentration is used in that critical range of concentration that they act. Okay, so when an insufficient concentration is used, all the anodic areas may not be covered, and resulting combination leads to the considerable increase in current density. Now what are those substances that can be used as anodic inhibitors? They are the alkalis. Alkalis can be used as anodic inhibitor. The molybdates can be used. Molybdates can be used as anodic inhibitors. The phosphates can be used as anodic inhibitors. Okay, they inhibit the reaction of the anode. And the chromates can also be used as anodic inhibitors. Okay, the next type of inhibitor is the cathodic inhibitor. Cathodic inhibitor, as the name suggests, ये cathode के reaction को inhibit करेगा. Okay, now if you remember, there were 2 conditions at the cathode, either it is acidic or it is neutral or alkaline. So in acidic medium, cathodic reaction was it was H plus. I'll write it down over here. It was H plus and taking up the 2 electrons and giving us H2. Okay, this was in case of acidic medium. So the corrosion can be controlled here by slowing down the diffusion of H plus ion. So H plus ions का diffusion slow कर दीजिए, corrosion process slow हो जाएगा through the cathode. Okay, it can be done by using organic inhibitors like amines. So what are those inhibitors which you can use over here? They are amines, cathodic inhibitors. They are amines which can be used. Okay, they are heavy metal soaps, thioureas. So I'll write down thioureas, heavy metal soaps. They are just soap-like materials. Okay, substituted ureas, thioureas, mercaptans, they can be used as cathodic inhibitors. How do they work? They get absorbed over the cathodic material surface and act as protective layers. So if this is the cathode, they are absorbed at this portion. Okay, and they act as protective layer. Antimony and arsenic oxides, they deposit adherent film of these particular metals at the cathodic areas, thereby considerably increasing the over voltage of the hydrogen evolution and undergoing the reaction. Okay, so anodic inhibitor ने क्या किया? एनोड के ऊपर जो रिएक्शन है उसको रोक दिया. कैसे? जो मेटल आयन बन रहा था उसको कैप्चर करके उसके साथ मिलकर एक प्रेसिपिटेट product बना लिया है which covers the entire surface of the metal. If I'm not using anodic inhibitor, I'll go for cathodic inhibitor. Cathodic inhibitor पे क्या होगा? Cathode पे, if you remember, there are two situations, either it is acidic or it is alkaline. So if it is acidic, it will capture the H plus ions. Okay, and then it will convert it into some inorganic layer which gets coated over the cathodic area. Okay, Likewise, in the case for the alkaline medium, there is no need for that. Third type of inhibition is using the vapor phase inhibitor or volatile inhibitor. This is very interesting. These are the organic inhibitors which can volatilize easily. आराम से ये वेपर फेज में कन्वर्ट हो जाते हैं, सबलाइम हो जाते हैं, सब्लिमेशन प्रोसेस हो जाता है इनका डायरेक्टली फ्रॉम सॉलिड टू द वेपर फेज. ओके, एंड सो दे readily sublime, and when they sublime, the fumes that they give, those fumes, they form a protective layer on the surface of the metal. Like for example, the anodic inhibitors, or let's say the volatile corrosion inhibitors. I'll write on the example over here. So one of the example which is most commonly used, actually, this is dicyclohexyl ammonium nitrate. So dicyclohexyl ammonium nitrate, okay, DCHAN. You can also remember it like this, DCHAN. These are the vapor phase inhibitors or VPIs. Okay, they are used for the protection against corrosion of the metallic parts which in small closed containers. If you have come across the delivery of the articles which you order, so some of the machines, if you order big machines, so let's say some articles which come from abroad, they take a lot of time to reach us, and we know that these the machine parts are packed up into very, very small packets. So in those packets, these vapor phase inhibitors are already there, which actually prevent their corrosion of those machine parts. They are also used in compressors and condensers. So this is vapor phase inhibitor. So what is the second choice by which prevention of corrosion can be done? Use of inhibitors. Inhibitor is a substance which inhibits the process. And what process? Accordingly, it can be anodic inhibitor, जो anodic reaction को inhibit करता है, cathodic inhibitor, जो cathode पर reaction हो रहा है उसको inhibit करता है, and third is vapor phase inhibitor, जो कि vapor phase में convert होकर आपके surface को cover कर देता है, and it inhibits the corrosion process. The third method to prevent corrosion or protect the metal against corrosion is the cathodic protection. इसको हम electrochemical protection भी कहते हैं. Okay, we know that in the corrosion reaction, the metal gets oxidized at the anode, and at the cathode, if it is acidic medium, those the H plus ions accept the electrons and get converted to H2. So from these reactions, we can make it clear that by forcing the metal to behave like a cathode is the principle of cathodic protection. So here we protect the metal or the metal surface by forcing the metal to behave like a cathode. Now, since there will not be any anodic area on the metal, the corrosion does not occur. This is how we prevent the corrosion or protect the metal against the corrosion. So there are different types of cathodic protection methods. Like number one, which is very, very important, it is called as sacrificial anodic protection. Means, what does it means? It is the protection. I'll break this terminology into three parts and you will learn the meaning, and you yourself will come to know what is happening over here. It is the protection of the metal surface by combining with another metal which sacrifices itself. How? By behaving like an anode, because you know anode corrodes, and anode is the one who is sacrificing everywhere in the corrosion. So the metal structure can be saved from corrosion by connecting it with a wire to a more active metal, so that the corrosion is concentrated at the more active metal piece, and as the more active metal is sacrificed in the process of saving the metal from corrosion, we call it as a sacrificial anode. Okay, so and the metals commonly used as sacrificial anodes are zinc, aluminium. So we can use aluminium, we can use zinc, we can use magnesium and their alloys. Now let's try to understand it with the help of a brief diagram. How does actually it works? Okay, So we have let's say we have this earth surface, and I have a pipeline going in the soil. This is all soil around it. Okay, so this is my iron pipeline. Okay, iron pipeline. Okay, I want to prevent this pipeline from corrosion, because definitely some water supply is going on. Okay, so what do? I connect this iron pipeline with the help of a wire. I connect it to some other metal piece. I just take a simple piece of metal which is more active than iron. And how do I know which is more active? From the galvanic series. I refer the galvanic series. So I have taken a magnesium piece of metal which is more active than iron. Okay, and so what will happen? This magnesium will function as an anode, and my iron pipeline will function as a cathode. So I have forced this iron pipeline, which I want to save, to work as a cathode. Okay, so when the magnesium functions as an anode, this is called as sacrificial anode. And what are the reaction going on? This magnesium will undergo oxidation. So magnesium will oxidize to Mg+2 and 2 electrons. Okay, and iron will be safe. Now since magnesium is sacrificing itself for the sake of saving the life of iron pipeline over here, so this is called as sacrificial anodic protection method. This is very important topic. Okay, usually zinc is used as sacrificial anode in good electrolytes such as seawater. Magnesium is used in high resistivity electrolytes, such as we use it in soils when we do want to do any such type of protection. Okay, the important applications of this technique are: it is used to protect the underground cables, underground pipelines from soil corrosion. It is used to protect the ships, the boat hulls from marine corrosion, wherein the sheet of magnesium or zinc are hung around the ship hull of ocean going ships. These sheets being anodic to iron, they get corroded, and hence sacrificial anode. And the third application is the formation of rusty water is prevented by the insertion of magnesium sheets or rods into domestic water boilers or tanks. Okay, so I have a boiler. There also you can use these sacrificial anodes. So I have a boiler, and it tends to get corroded after some time. So what do? I just hang a piece of zinc or magnesium, which actually act as sacrificial anode. Okay, fine. So these are the applications of sacrificial anodic protection also. Okay, fine. The second type of cathodic protection is impressed current. Okay, so the second type is impressed current. IMPRESSED, impressed current. Now what is this impressed current? Impressed current, cathodic protection. I'll write CP for the cathodic protection. Now in this method, current from external source is impressed. Impressed means applied in the opposite direction so as to nullify the corrosion current. Now this is done to convert the corroding metal from anode to cathode. मतलब हमने यहाँ पर भी अपने मेटल को, जिसको हमें सेव करना है, उसको ज़बरदस्ती हमने कैथोड बना दिया. कैसे? By connecting it to the negative terminal of the battery. So once the metal becomes cathodic, it is protected from the corrosion. The anode may be either an inert material or one which deteriorates and will be it can be replaced periodically. The commonly used anodic materials are graphite, carbon, stainless steel. So I'll write down here the commonly used material in impressed current cathodic protection. It can be graphite that you can use. Okay, it can be carbon, it can be stainless steel, scrap iron also, scrap iron, stainless steel. Okay, so I'm sorry. Okay, fine. Silica iron also can be used. Okay, anode is buried in bag fill, such as in a bag which is such as gypsum, to increase the electrical contact between itself and the surrounding soil. Anyway, if you want to have a look at the diagram, let's see how it looks like. This is your earth surface. Okay, fine. and I have this buried pipe made in the soil. This pipeline is mine, which I want to protect. Okay, and this is all soil around it, and you know what is the environment in the soil related to acidity, moisture, humidity, electrolyte, ions, salts, etc. Okay, so this is the buried pipe which I want to protect. Okay, and I have forcefully made it a cathode. Okay, so pipe which has been made a cathode. Why? Because I want to protect it. Now how do I forcefully make it a cathode? By connecting it to the negative terminal of the battery outside. Okay, and another metal which I have taken and I have connected it to the positive terminal of the battery. Okay, so this is, let's say this is my this is graphite or carbon or scrap iron or stainless steel, whatever I have taken in that and backfill. Okay, and I have connected to the positive terminal of the battery. So when such thing will happen, when I do it this way, my pipe, iron pipe, will start behaving as a cathode. Okay, so this protection method is useful when the electrolyte resistivity and the current requirements are high, and it is well suited for large structures, long-term applications. Maintenance and operating costs can be reduced by employing automatic impressed current cathodic protection. Okay, and it is used in the case of buried structures such as pipelines, tanks, transmission line towers, laid up ships, and so on and so forth. So this is cathodic protection. Let's have a quick recap. Cathodic protection मतलब मैंने अपने मेटल को कैथोड बनाना है ज़बरदस्ती और उसको प्रोटेक्ट कर लेना है, क्योंकि कैथोड बनेगा तो वो करोड नहीं होगा. ओके, हाउ डू आई डू? दो तरह से हम कर सकते हैं. सैक्रिफिशियल एनोडिक प्रोटेक्शन मतलब मेटल को प्रोटेक्ट किया. कैसे? उसको एक और मेटल से जोड़ दिया जो कि बेचारा अपने आप को सैक्रिफाइस कर गया. कैसे? क्योंकि वो खुद एनोड की तरह बिहेव कर. और वो हमने मेटल कैसे चूज किया? फ्रॉम द गैल्वेनिक सीरीज विच इज मोर रिएक्टिव देन द स्ट्रक्चर दैट वी वांट टू प्रोटेक्ट. ओके, सेकेंड इज इम्प्रेस्ड करंट कैथोडिक प्रोटेक्शन मतलब मैंने जिस मटेरियल को प्रोटेक्ट करना है उसको नेगेटिव टर्मिनल ऑफ द बैटरी से कनेक्ट कर दिया ताकि करंट का डायरेक्शन रिवर्स हो जाए और वो हमारा कैथोड बन जाए. एंड द अदर मेटल विच आई एम नॉट इंटरेस्टेड इन, इट बिहेव्स एज anode. So this is cathodic protection. These are two ways of protecting the material or the metal that I want to protect. The next is, the third way is to use protective coatings. Now what are coatings? Definitely very simple word. कोटिंग कोई भी एक ऐसी लेयर जो आप अपने मेटल के सरफेस पर लगा देते हैं एंड इट प्रिवेंट्स और इट एक्ट्स एज अ बैरियर टू द अंडरलाइंग मेटल सरफेस. मेटल कोटिंग्स, there are actually surface coatings made up of metals are called as metal coatings. ठीक है, otherwise it can be organic coating also. ओके, मेटल कोटिंग्स अपने आप में दो तरह की होती हैं. एक होती है एनोडिक कोटिंग, दूसरी होती है कैथोडिक कोटिंग. जैसे कि आपका आयरन को आप गैल्वेनाइज करते हो. सो इन दीज कोटिंग्स द मेटल यूज्ड फॉर कोटिंग is more anodic than the metal which is to be protected. So जो more anodic आपने coating जिसकी बनाई है वो anode है, corrosion उसका होगा, underlying metal आपका बिल्कुल safe रहेगा. For example, coating of aluminium, zinc, cadmium on the steel surface. In galvanized steel, zinc is coated, is the coating metal, and steel is the base metal. So zinc is more anodic. It is attacked, it is corroded, leaving the underlying cathodic iron or steel unattacked, even if it is exposed when pores or breaks or continuous discontinuities occur in such anodic coatings. So iron or steel is not corroded till the time all the coating of the zinc has been consumed. The second is the cathodic coating. These coatings protect the underlying base metal because of their nobler character and high corrosion resistance. होता क्या है, इन कोटिंग्स के थ्रू, कैथोडिक कोटिंग्स के थ्रू प्रोटेक्शन पॉसिबल होती है ओनली व्हेन दे आर कंप्लीटली कंटिन्यूअस एंड फ्री फ्रॉम पोर्स और ब्रेक्स और डिसकंटिन्यूटीज, जो कि एनोडिक के केस में नहीं है. वहां पर अगर पोर्स प्रेजेंट भी है तो भी आपका मेटल जो है वो करोड नहीं होगा. यहाँ पर मेटल करोड हो सकता है. सो डिसकंटिन्यूटी नहीं होनी चाहिए कैथोडिक कोटिंग्स में, पोर्स नहीं होने चाहिए, ब्रेक्स नहीं होने चाहिए. इफ द पोर्स, ब्रेक्स और डिसकंटिन्यूटीज दे आर देयर इन सच अ कोटिंग, द corrosion of the base metal is speeded up. This is due to the fact that exposed metal act as anode and the coating becomes the cathode over there, right? So a galvanic cell is set up and an intense localized attack at the small exposed part through those pores and pits and cracks occurs. Okay. So if we see the difference between the anodic and cathodic coating, anodic coating protects the metal from corrosion sacrificially, but cathodic coating protects the metal from corrosion due to its higher corrosion resistance, right? In anodic coating, base metal is not corroded even if it is exposed till all the coating gets consumed, whereas in the cathodic coating that is not the case, because even if small cracks or pores are present, it leads to the speed of corrosion of the metal surface. इसके बाद आता है ऑर्गेनिक कोटिंग्स. ये था मेटल कोटिंग्स और उसके टाइप्स. ऑर्गेनिक कोटिंग्स, इट इज़ एन एस्टैब्लिश्ड प्रैक्टिस फॉर अस टू प्रोटेक्ट द मेटल सरफेस by using paints, varnishes, enamels, lacquers. These all are examples of enamel coatings. How do they function? They protect the metal from corrosion to impart, and they are also used to impart decorative and aesthetic appeal to the metal. Okay. How do they function? They are more inert organic barriers, and their protection depends, or the protection or the protective value depends on the chemical inertness to the corrosive environment. It has a good surface adhesion, its proper application method, and the protective value also depends on impermeability because of its impermeability to the gases, salts and water. So these are the stories of metal and organic coatings for prevention of corrosion.